So we're moving into this section here, and the lab now, or sorry, the archive with this section is fairly significant. As you see when I walk through the slides, I briefly talked about the lab the last day. So these are the slides, and we're just digging into the component model in a lot more detail, in the sense that we want to make our components interactive and dynamic. And when you add dynamics to any aspect of programming, that usually complicates things, but such is life. So these are the topics I want to cover. I want to look at something called component state, which is really at the root of making components dynamic. Dynamic means that they change what they display to the user, typically based on the user interacting with them, but not solely that. Then I'll talk about the virtual DOM. We know what the DOM is in the context of the browser. What React did was they introduced a kind of second DOM into the equation, which kind of sits between our React code and the browser's own DOM. I often refer to the browser's DOM as the real DOM, as opposed to this virtual DOM that React provided. That was an innovation by React at the time. A number of other single-page app frameworks use this virtual DOM idea now. Then I'll talk about how data actually flows within a React application. We know at this stage that a React application is a hierarchy of components. How does data flow between those components? And the last thing I'll look at is something called hooks. Hooks are really important, and are we okay? People can hear me, can they?
Yeah, that's perfect.
Okay. Hooks then was only introduced actually early 2019, but if you do any Googling now on React, then the code that you will see will involve these hooks. Prior to February 2019, the way we actually implemented React components was as a JavaScript class. But that's irrelevant now because we no longer do that. So anyway, component data. Now, what we know so far is that we can provide data to a component in the form of props, and props are passed in typically by a component's parent. Prop data is immutable, and the props are accessible by the component via this props object, which the React framework creates for us. Now, there is a second aspect to a component's data, and it's kind of everything that props isn't. This second aspect is called state. State data is data that is managed internally by the component. It is mutable, it can be changed, and that mutation is really at the center of making a component dynamic. The state data of a component can be of any type. Prop data can be of any type as well, but state can be. So state data or a state variable for a component could be an integer, a string, an array, an object, anything. And a component can have many aspects to its state, or in other words, it can have many state variables, I guess. Just before I move away from props, something that I did mention the last day, purposefully really, because I didn't want to complicate the issue, but props are something that are passed into a component, as we know, but quite often in real life, you will be developing components that other developers may be using. And so other developers, may not use your component properly. By that, I mean, they may not pass in certain props that are expected by your component, or you may actually provide the option of having optional props. But either way, there needs to be a way of programmatically assigning a value to a prop if a prop is not an explicit prop instance isn't actually provided by whoever is using the component. So in other words, we need to be able to programmatically declare default values for props. Also, when you have this kind of scenario where people other developers may be using a third-party component or a component that you developed, you may want to do some basic type checking on the props that they provide to your component, just make sure that they're using it correctly. So there is a way of type checking the props before you start using them, because if an incorrect prop type is passed into a component, then potentially the component will crash. So at least have some way, we'd like to have some way of reporting back to the other developer that you're not actually using a particular prop properly, or you're passing in the incorrect type of prop. They're just fringe issues really, but anyway, they're there. Similarly, like in relation to state, even though we haven't looked at how do we add state to a component, but state, as I said, is data that's declared internally by a component. And so in that declaration, now we're not going to be declaring state data in the normal way. We're not going to be using kind of the let statement or the const statement. We'll be using a special mechanism, but we do need to have a way of initializing our state variables. We do need to have a way of mutating them. We won't be able to mutate or change a state variable by a simple assignment statement, as we'll see. That ain't going to work. So we need to see how we can do all of these things programmatically. By way of example, I'm using the kind of 101 illustration. So the little picture there on the right is my way of representing this component that I'm going to show you. And what the component expects as a prop is an integer, which I'm just calling jump. And the yellow box in the middle is my way of representing the state aspect of this component. So the state just comprises of one part, and it's going to be an integer variable, if you like, and its initial value is going to be 0. Now, as well as you'll see, this little counter component is going to have a button. When the user clicks the button, my component is going to add the jump value to the current count value. In other words, it's changing the state of the counter. Now, I think I mentioned it on the previous slide, or I'll mention it subsequently. The whole idea of state variables within a component is when the state variable changes, what React does is it re-renders the component, or it re-executes the component. Can I just go back to the previous slide? Did I actually say that? Yeah, I see the very last line there on that slide. When you mutate or change the value of a state variable of a component, that component is automatically re-rendered or re-executed. And of course, the re-execution of the component function may mean that the component now renders something slightly different, i.e. it's dynamic. So the state data is what is at the core of making a component dynamic. And this is because whenever you change the state, the value of a state variable, what React will do is to re-execute the component function. Right, so the example is contained within the archive on the right. So download it, unzip it. There's lots of other stuff in the archive as well. And you'll see from the archive, I just bring it up. So the archive will actually contain 3 subfolders, and clearly this is the one that contains the counter component illustration. And what you've got to do is I'm giving you the component, you've got to kind of add it to your basic React lab project from last week. And you've also got to add a few stories to the stories file. That's all explained in the README anyway. So the end result of following the instructions in the README is you now have this new component in your examples folder within the basic React lab. And I've also added some new stories. So if I just start up Storybook maybe, and just show you the component running.
Watching have sex every day, but I mean, ideally watch every day. How much were those sunglasses?
It's this one here at the end. Now I have 3 stories associated with it. I'll come back to that later on, but I just take the normal story. This is how it renders, and it has a button that allows me to interact with it. The increment size is my jump value actually. So it looks like 3. And here's my counter value. And every time I click the button, it's just going to increment the count. So A, my component is interactive by clicking the button, and B, it's dynamic. Okay, the dynamics is fairly minimal, but this part of the component is changing every time I click the button. So let's look at the implementation. So let's just look at the bottom first. This is its JSX, which is standard enough. The only thing that's slightly new, okay, is it's got a button. This is ordinary HTML, and the button has an on-click event handler associated with it. This is referring to a local function declared here. We'll look at the detail in a second. Now, here's the kind of critical line, really. This is how you declare a state variable. So there's a special function called useState, and you can see I'm importing useState from React itself. So it's a React function. useState function takes an argument. The argument is the initial value that you want to give to the state variable. So I'm initializing it to 0. So it looks like my state variable is an integer type. The useState returns an array. What we're doing over here is destructuring, which I talked about at the end of last week's lecture. The useState returns an array, and the array comprises of 2 parts. The first element in the array is a reference to the state variable. The second is a function which you can use within the component to change the value of the state variable, i.e. mutate it. You can call these things anything you want to, but you need to remember the ordering of them. First one is a reference to the state variable. Second one is a function that allows you to mutate the state variable. Now, I am saying that this count state variable is managed by this component, but the actual physical memory location of where the state variable exists is actually taken care of by React by virtue of this function here. Like, normally you might think, well, if the state variable is managed locally by the component, then you might expect you would have seen something like this equals whatever. But because it's a state variable, and the real importance of a state variable is this idea that when it changes, what React will do is re-execute your component. That wouldn't happen if we declared our state variable like this. So it's a special type of declaration, and you do it via this special function called useState. So anywhere within the rest of my function, anywhere I refer to count, I will be referring to the current value of the state variable. And anytime I want to change that, I need to do it via this function. I can't change it by an ordinary assignment statement. So where do I change it? Well, it looks like I change it here. So back again to my button, it has an on-click handler. When the on-click, or when the user clicks the button, this function executes. There's only one line of code inside this function. We call the special function that was returned by useState to mutate our counter. And I'm doing what I said I was going to do, which is add the jump prop that has been passed in to the current value of count. Now, what's important to note is that when this function is executed, 2 things happen. One, clearly the value of my count state variable changes, but 2, React re-executes my entire component function. And what we say is it re-renders your component. It executes it from top to bottom. So from an execution point of view, the flow is user clicks on button, button has an event handler executes, event handler changes the state variable, React then kicks in and re-executes your component, re-renders it. But of course, because one of the things in my component is to display the current value of count, which I'm doing here, then my component is displaying something slightly different from what it was displaying before the user clicked the button. Is there any question about that? There's some more stuff down here I'll talk about in a minute. No? Okay. Just in sorry, yeah.
You see where you have the props.jump, does he like increment it by 1 or by a certain number, basically?
Depends on what jump value was passed into the component, but that's just a prop. I'll show you the story in a second. Let's look at the stories, I suppose, but the stories aren't terribly interesting, but let's look at them. So I've just added 3 stories. I'll talk about why I have 3 of them, but if you just take the normal one, okay, I've decided jump is equal to 3. And that was the story that I demonstrated, I think. I'll do it again. Yeah, so the 3 here is confirmed from just displaying it there. So that's just to help us to understand. Right, that's the essence of state in the context of React. What I was about to say, though, unless there's another question. No, okay. I wouldn't dwell on it too much, but there is something unusual behind the implementation of that useState function. What I mean by that is the first time this component executes, count is going to be 0 because that's what I passed to useState. When the setCount function is executed, I said that the function, the component function, re-executes from beginning to end again. But useState is clever enough on this second execution. useState is clever enough to know I'm not going to return 0 as the value for count. I'm actually going to return whatever it should be incremented by. Like normally, when you call a function within another function, then the function that's been called returns the same thing every time, but useState doesn't. It actually returns the updated value for count. Okay, it returns the same function, the setter function as we call it. That's just by the way. It's just that the implementation of useState is quite clever in that it knows whether this is the first invocation of useState or is this a subsequent invocation of useState. If it's a subsequent invocation, it knows not to reset. In our case, it knows not to reset the counter back to 0. Okay.
How long does that go on for? Like, how long will that stay persistent in your code?
Yeah, good question. It stays that way as long as the component is still visible on the browser. If you bring up another component. Right. So when I clicked on normal story there now, it essentially reset everything back to the beginning. Like technically what I would say is whenever the component is unmounted from the DOM but that's, I'm going to talk about this notion of mounting and unmounting later on. But the quick answer to your question is, once the component is not visible, which it isn't now, when I come back and click the normal again, it just starts all over again from scratch. Anything else?
No, that's for me. That's fine.
Yeah, that's fine. Yeah. Okay, so just remember the fundamentals of state, because once you start adding, and you can call this many times, you know, if you've got a number of other state variables, you just repeat this line for every state variable. How do you identify the state variables that are required for a component? We'll talk about that later on. Not an issue now. Now, down at the bottom, I've got just one or two other things that I'm just going to cover in passing. To be honest, I don't use them a lot. Maybe I should, but I don't. It relates to props. In the slide there, I said that we should be able to programmatically give a default value to a prop if the developer didn't provide one. And also we should be able to do some basic type checking on props. This is the actual way how you code it. It's quite messy, but anyway, I'm just showing it to you just in case you come across it in any blogs that you might read. I'm using a special library called the prop types library. It's separate from React really. And you know, you could kind of work out what's the effect of this bit of code is. This allows me to give a default value to the jump prop. So I've decided to default it to 2. This is how I programmatically declare what type of thing jump should be. So this props type library, it's very expressive really. You know, if you had a prop for a component that was an array of objects where the objects had to have certain keys in them, then you can express that complexity using this prop type library. We won't get into it, but it is very powerful and very expressive. So no matter how intricate or how complex your props might be, the props type library allow you to declare both the type of the props and also the initialization of it. If I go back to the stories where the default value for the prop is illustrated is this example here. So you see in this story, I'm not providing any value for jump, but according to the code that I showed you there a moment ago, I said that the default value would be 2. So if we look at this story, the default story, then, you know, there we go, and it behaves fine. The third story is applying the type checking on my prop. According to my code, the type checking code said that jump should be an integer or a number, I think is what it actually said, wasn't it? How it expressed it. Yeah, it should be a number. So supposing we try to do, you know, this. Now it's not as sophisticated as you might think, because if I bring up the story, then that's what happens. Now that's only because of the weakness of the plus operator in JavaScript, but really the purpose of the type checking on the props is not so much for a runtime type checking, it's really developer time. What I mean by that is when you're doing any kind of web-based development, then you should always have your developer console open. And if I just do a refresh, you see this error message here or warning message. This is coming from that type checking code that I have in my file, in my component. So this is really a warning to the developer. You better check your code because I think you're using this component incorrectly. So that's as far as the type checking goes really. So before I move away from it, don't think there's anything else. Just by the way, it's a JavaScript thing really, but if we just go back to basic JavaScript, this is a function, counter is a function, and I'm declaring a function inside the body of it. Now, this is just a declaration though. This does not cause the function to execute. I'm just declaring the function. Now, in my case, the only time this function executes is as a result of the on-click handler. In general JavaScript, if I actually want to execute this function, then I just have to invoke it in the normal way, i.e., just like that. So anyway, it's just a declaration, right? That's state. So this useState method, it's actually one of these what are called React hooks. There are many other ones, but and it returns what I said it returns. It returns an array, and you destruct the array. That's just a JavaScript point that I'm making at the very bottom there. What is it? Oh yeah, like from a syntax point of view, these things are called kind of static properties, because you can see here, I'm actually using the function name and I'm accessing a property called the default types property of a function. That looks kind of odd, but what's actually behind it from a JavaScript point of view, functions are actually objects as well in JavaScript. But if we start going down that route, then we just get into a knot really. But so just take this as syntax as to how you assign default values and do prop type checking. I don't use this at all in any of my code that I give you, and which is poor programming from my point of view. But anyway. Just briefly, so we saw in that little example how we do some event handling within our React code, and it's very like how we actually do it in native JavaScript in the browser. So React, the React's event handling model is obviously independent of the browser that is running it. Otherwise, your React apps would only work in certain browsers. So we know from last week or the previous week that the browser is an event-driven programming environment. And as the user interacts with a browser, with the UI in the browser fires events. That's just native to how browsers work. What React does is it catches those events and it wraps them in a wrapper, and the wrapper is called a syntactic event. Again, it's just for completeness. It wraps them anyway, so that, and the reason it wraps them is because it shields you as a developer from having to worry about, well, is this code running in a Firefox browser or a Chrome browser? Because the syntactic event object that you can deal with, it's an object that represents the event. The code that you write against it can be independent of whatever browser you're running in. The other thing I'm mentioning just in the table here is that, like, in the event names native to the browser are all on something where the word after the on is lowercase, whereas React kind of capitalizes. That would only be of interest to somebody that might have done some native React and some native JavaScript programming in the browser, to have to flip from this to this. Okay, so it's just camel case, isn't it? Is the format of the various event names. If you want a full list of events, you can get them here. Right, so that just covers off the React event system, and really it's 99% the same as the browser's native event system, except for the change that I'm mentioning in the table here. And really, apart from that, you needn't worry about the rest of it. So just to reiterate, This is the sequence now that happens when the user clicks the button. They click the button, that triggers our on-click event handler. The event handler changes the state of the component. And from there on in, React takes over. So React is doing this part here. React changes the value of the state variable, but critically, it re-executes your component function. And of course, you could have some conditional statement inside in your component body, which completely changes the structure of what's being displayed by your component. So that's where the dynamics kind of really kick in. Let's park that for a second and go back to this whole area of the DOM. The DOM is this data structure that's built up by the browser when it receives a raw HTML page. And anytime you have JavaScript that changes the DOM in the browser, then the browser will honor that change by repainting the screen. We know all that from 2 weeks ago. Now, in the early days of web apps, like web apps predate React and predate single page app frameworks. People were developing web apps for a number of years. But when they were developing web apps, they were actually taking care of writing the JavaScript code that modified the DOM data structure that comes with the browser, using what's called the DOM API, which I briefly mentioned on week 2, let's say. But you had to be aware as a developer of what was good practice and bad practice in terms of DOM manipulation, because if you applied bad practice, then what it really meant was that the UI experience for the user was poor in terms of the refresh rate and all of that. So in the early days of web app development, you had to gain a lot of knowledge as to how best you should program your DOM manipulation code. That's roughly kind of what I'm kind of getting at here. We like to have ... because there are loads of other things I could talk about, but there were good practices and bad practices. Now, what the React design team asked themselves was, should we still require the developer to gain all of this understanding of what's good practice and bad practice in terms of DOM manipulation? And they decided, no, that's not a good idea. Let's actually build the DOM manipulation into the React framework itself and relieve the programmer, the developer, of all of those headaches. And the way it did that was it introduced something called the virtual DOM. The virtual DOM is a much more efficient data structure than the real DOM. The real DOM is the DOM that the browser actually manages itself, because the DOM has been part of the browsers from day one, even back in the days of the static website kind of era. So the React team introduced this virtual DOM. And so what it means is you write components. When your components re-render as a result of state change, really the re-rendering is making changes to the virtual DOM data structure. And React then monitors changes to the virtual DOM. It looks at what has changed in the virtual DOM and it applies those changes to the real DOM. And of course, when the changes happen to the real DOM, then the browser clicks in and repaints the screen. Now, in a very large React app, where there are many, many components and many of them are re-rendering, then there could be quite a lot of changes happening to the virtual DOM. React kind of batches all of those changes, works out what is the most efficient way of applying these changes to the real DOM, and then it applies them. So it sits between, the virtual DOM sits between your React component code and the real DOM in the browser itself. This is kind of in English how a React application works in this case, or at this stage now. So when your JavaScript code is sent down to the browser, this is your transpiled React code, is sent down to the browser. And in that JavaScript code will be the React framework itself. The React framework builds a builds this virtual DOM instance as a mirror of the real DOM. And point two then is, as your app changes, in other words, as the user interacts with the app, that triggers some of your components, those components that have state, to re-render. They apply, that re-rendering causes changes to happen to the virtual DOM. React then does a diff operation between the new state of the virtual DOM, or the new status of the virtual DOM, and its previous status, computes the difference, and then decides how best to update the real DOM as a result. So that's kind of all going on behind the scenes. You could happily be a React programmer and not really know about the virtual DOM's existence, but it's always good to have an understanding of at least one level below where you're programming at. So that's this idea of the virtual DOM. And, you know, it means really that, and I've mentioned before to you, that web apps back in the early days, the JavaScript code that you wrote was spaghetti code, highly unmaintainable, very bloated. But now, as a result of this virtual DOM and other things as well, your code is much cleaner, and definitely the user's experience is better because the modifications or the updates that are happening to the real DOM are being optimized by React. Yeah, so kind of this is now an expansion of what I had about 2 or 3 slides back. So this is now really what's happening. Once, in our counter example, once the user clicks the button changes the state, a variable for that component, and then, you know, React does all of this stuff. It re-renders your component, it re-executes it. That causes a change to the virtual DOM. It then does a diff between the new state of the virtual DOM and the old state, and then it applies the batch. It batches those updates to the real DOM. You know, where this is really important is if there are a number of components that are re-rendering after the user, as a result of the user interacting with the UI. That's the virtual DOM. Next, I want to talk about data flow within a React app. So what I'm showing you here is a generic architecture or design, sorry, for a React application. We know from an earlier lecture, I have said that every React application that you ever develop will be a hierarchy of components. And that's what I'm kind of illustrating here. So, and I'm also just using some color coding to distinguish between components that have state and those that don't. And so I've decided that if it's just an ordinary white box, it's a stateless component, doesn't have any state variables. If it's a, I don't know, is that orangey or brownie box, then it's a stateful component. And that's point number one. And as I say on the next slide, really the vast majority of your components in a React application will be stateless. Only a small subset will be stateful. We'll talk later on about how you actually come up with a design for a React application, but just take that statement as fact for now. The vast majority of your components will be stateless. Also, what I want to get across in this slide is the idea that data only flows in a downward direction, i.e. there's only unidirectional data flow allowed in a React application. And so that's what I'm illustrating here in terms of props. And we know it's props that are actually passed between components, but props can only go in a downward direction. That was a conscious decision made by the React team because other single page app frameworks that existed at the time allowed data flow in 2 directions, which was referred to as bidirectional data flow. The upside of bidirectional data flow is you could get things working quicker in those frameworks than you could with React. You could learn them you could learn the framework more easily. The downside of bidirectional data flow is that once you had a complicated application, it was actually quite difficult to debug. And that was really why the React team decided, let's not have bidirectional data flow. Let's only support unidirectional data flow. It is a constraint then on you as a developer. So the learning curve for React is slightly more challenging than, let's say, something like the early days of Angular. But now, the other point I want to make as well is, what do I mean by this relationship here? You know, this is not anything got to do with inheritance now. What I mean by this relationship is that if we looked at the JSX, or the return statement of this component, included in it would be a reference to this component. That's all I mean by this, this relationship here. Okay. Now I'll probably come back to this diagram a couple of times during the rest of this lecture, but the key point for now is props can only go in a downward direction. What do we say on the next slide? In a React app, data flows in a unidirectional only. I am saying that, yeah, I've already made that second point, that's the way it actually kind of works out in most cases when you're developing React apps. Only a small subset of your components need to be stateful. You really want to try and keep as many components stateless as possible, because the more state that you have scattered around your component hierarchy, the more difficult it is to do any kind of debugging when things start to go wrong. So you've got to choose where state should be and have as little state as possible. Again, I'll talk about how you make those decisions later on. So what I'm saying now, and the last bit here, is that if I explain it really rather than talk through it. So this component here, I'm saying, is stateful. We don't care about what the nature of the state is, but so the user interacts with this app, and as a result of that interaction, let's supposing this component state changes and it re-renders. But not only does this component re-render, its children re-render as well. And there are new props passed down to the children. The actual prop values might be the same as before, but it's a completely new prop object. So as far as this component is concerned, I've got a new prop object. But when this component re-renders, React also re-renders this and this. And of course, if this component re-renders, React will automatically re-render its children. So the net effect is, whenever the state of this component at the very top changes, every component in the hierarchy re-renders or re-executes. Now that might sound like an awfully inefficient way for a React application to work. But it's possible that even though these components, let's say all these components re-render as well they do, but let's supposing nothing changes in terms of the virtual DOM, then React is clever enough to realize, well, there's no change between the current virtual DOM and its previous state. So I don't need to worry about updating the real DOM at all for whatever part of the UI is controlled by these components here. So that's where the kind of efficiency, it sounds very inefficient when I said, first of all, whenever this component re-renders, every single other component re-renders. But the efficiency kicks in as a result of the role that the virtual DOM is playing behind the scenes. Right, so there's a lot going on really, or I'm trying to get a lot across by virtue of this drawing, and the points are being reinforced there in text. But essentially, data flows only in a downward direction. Right, next, hooks. What are hooks? Hooks are pretty new because React came out in 2012, but hooks are only around since February of 2019. but they are the standard diet now in this case, so we can't go back to the way they were before 2019. And in fact, to take it from me, it was a little bit more complicated pre-2019. So what are they anyway? Well, number one, this thing called React hooks, and I can explain later on why they call them hooks. But number one, they're just ordinary functions. Some of them are higher order functions, so they take callbacks. And what they're about, point number two there is, they're all about allowing you to programmatically manipulate the state of a component and also manipulate the life cycle of a component. Talk about life cycle maybe later on, but they essentially kind of allow you to hook into how React manages all the rendering that it does of your components. They're extremely important. Point number three there is not really relevant to E because, okay, hooks only came about in February of 2019, but the notion of state in a component and the notion of components having a life cycle, that applied from day one in the React world. But the way we actually managed state and the way we manipulated components lifecycle pre-February 2019 meant that we had to implement our components as JavaScript classes, and we also had to inherit methods that were part of the parent of our component class. Our component class inherited from what was called just a React component superclass, but that superclass had methods in it, and we had to override those methods in our component implementation. So it was just a different programming model that came about as a result of React hooks, and it meant we write physically less code, but arguably it's a little bit trickier to follow the flow, as we'll see. There are many of these hooks, and they all begin with the prefix use. So we've already seen one of the hooks, the use state function. The use effect hook is the second most important one, which we'll see in the rest of this lecture, well, of this set of slides. And we'll see some other hooks later on down the line as well. So they all begin with the keyword use or the prefix use. That's purposeful because it actually allows the React linting tool, a linter. I don't know if you've come across linters in JavaScript or not. Linters are tools that will statically analyze your code. Nothing to do with React now. A linter is a tool that statically analyzes your code to see if you've got any kind of well understood coding errors in your code. Not so much logic now, because you see, JavaScript is an interpreted language. We don't compile it. Unlike Java, you compile Java before you execute it. And of course, the role of the compiler is to check that your code is syntactically correct. Linters do the same in the JavaScript world. And there is a linter that comes with the React framework. And one of the things it checks is to make sure that you are using these hook functions properly. And so how does it know whether a function is a hook function or not? Well, if it begins with the prefix use, then it knows it's a hook function. That's how it works. What do I mean by are you using the hook properly or not? And there's only one very simple rule, really. All of these hook functions, you can only call them from within the top level of a component. In other words, the only one we've seen now is use state. You can't call the use state function, let's say, inside an if statement in your component. It won't allow that. It'll just throw you an error at transpilation time. Equally, you can't call the use state hook within a kind of a for loop. So you can't nest it inside the body of a component. You can only use it at the top level within a component function. well, number 2 there is fairly obvious, I suppose. These hook functions only make sense in the context of a React component implementation. So they don't have any other effect if you call them inside an ordinary JavaScript. As usual, I don't make as much progress as I would like. So we've seen the use state hook. The second most important hook is the use effect hook. You might remember when I was talking about JavaScript and I talked about the notion of side effects in programming. This is just general programming now. A side effect, if you remember, is where a method or a function changes something outside of its own scope. We refer to that change as a side effect of the function or method. Well, this use effect hook is kind of in that whole area. So use effect hooks are a way of allowing components to have side effects. Now, what do side effects really mean in the context of web applications? There are really only a small number of side effects. The most important side effect that a component, a React component, might wish to have is to be able to make an API call or a HTTP call to a web API. Because clearly, if a component is trying to communicate with a web API, then it's reaching outside of its own scope for whatever reason, to get data, presumably. Another typical example of a side effect that a React component might wish to have is it might wish to react to browser events. The example I'm giving there is if the user resizes the browser window, maybe you want your React component to react to that. Now, the resizing of the window is clearly outside of the scope of the React component. So how do you have a piece of code within your React component that you want to have executed when the window is resized? And the way you do it is using this use effect hook. So the use effect hook is just a function. And in this case, it's a function that takes 2 arguments. It takes the callback and it takes an array. And the callback is really where you put the code that you want to have executed associated with the side effect. So if the use effect hook wants to make a web API call, then the web API call will be programmed inside the callback. If you want the hook to react to the resizing of the window, then you've got to put that kind of code inside the callback. The dependency array is that controls actually how often should the use effect hook execute. Now, we know that when a component, a stateful component, when it experiences a state change, then the component re-renders from beginning to end. And the question arises, well, do you want the use effect hook to execute every time the component re-renders? Or should it only re-render, should it only execute on certain re-renderings? And how do you express when it should and should not, when the use effect callback should and should not execute? And the answer is you do it by means of this dependency array. So I'm going to unfortunately freeze it there now in mid-flight, and we'll pick up the story the next day. I've already mentioned to you that you can happily do this lab because it's not using state and it's not using this use effect hook. One thing it is doing is it requires you to register with a web API, and I'm just wondering if the instructions that I've given you in the lab as to how you register is a bit out of date, because I registered with this web API about 3 years ago, but I'm not sure if they've changed their registration process. But maybe I'll just let you see if you are able to register for an account with the web API. The web API is called the TMDB, the movie database web API, to see if he can successfully register. And if one student can, then you might tell the rest of us how you actually registered successfully. But it's a bit open-ended now. So I have some labs tomorrow, web app labs tomorrow, so maybe I'll delve into it there. But you can still do this lab without having registered for the web API. You won't be able to do the subsequent ones, but so that won't hold you up. Right, I'll leave it at that, and I'll see some of you tomorrow in the labs. Bye for now.